Thank you, Don. Welcome, everybody. So we are here with the 5-axis configuration demonstration portion of our webinar. And one thing I should mention is that all the functionality that you're going to see today is available in our what we call the premium configuration. So you would need the premium configuration in order for you to actually run all these toolpath methods that I'm going to be showing. So let me talk very briefly about the different methods that we have. So if you do have the premium configuration, the machining browser is going to show up like that. And then you're going to have a 5-axis machining method drop down here. And the different methods that we have available in 5-axis are curve projection. It's very similar to 3-axis curve projection, except that you can take a curve and project it on a 5-axis mode. With normal surface normals acting to drive your machine tool angles. Flow curve is another type of machining where you actually select a curve and you allow it to walk along a surface or multiple surfaces and machine it in that fashion. Very similar to that is between two curves. For those of you who have the Pro configuration, you might be familiar with this, where you have take two curves, but this is on top of a surface or multiple surfaces, and this will basically morph between those two curves and create a cut pattern for you to machine in the particular geometry that you have selected. Drive curve, this is also another interesting method where when you have very complex geometry and very tight geometries where you can't really get in very easily, you can control the tool axis using this drive curve methods. Surface normal method is very similar to a parallel machining in 3-axis. Obviously, you're doing it in 5-axis mode here. It's a little bit more complex in terms of the computations and setups, but the principle is pretty much the same. And then we finally have the swarf machining method, which is unique to 5-axis. We're actually cutting with the side of the tool, typically in 3-axis mode. Or for even in 4-axis and many 4-axis methods, you're going to be cutting with the bottom of the tool or the sides of the tool, or rather the cutting portion in case of a ball mill. But in swarf, you're actually cutting with the side of the tool. You're driving the side of the tool along a wall to machine it. So these are the different types of methods that we have available in the pre-configuration. And as Don mentioned, you're not restricted just to using these methods in 5-axis mode. You can actually use them on your 4-axis machine. The advantages that you get with the pre or premium configuration is that you have many more toolpath methods to control your cutting process and thereby, machining different classes of parts that way. Okay, so that's a quick rundown of the different methods. I'll be going over and showing you different toolpath methods on different part files. Some of the things that Don mentioned in his slide. Before we run out of time, I hope we'll have enough time to show some of the complex features that we have. But before we get started, let me talk about the coordinate systems in CAM. This is very important to understand before we delve into the actual machining parts. And for those of you who are interested, deeper and a more thorough explanation of the coordinate systems, we did a webinar last month on index coordinates or index machining, and we went through a detailed explanation of the coordinate systems. But I'll briefly summarize it here so we understand what we're talking about in terms of the coordinate system definitions. Okay, so from our CAM system perspective, there's when you bring in a part file, let's say a very simple part file like this that I'm showing, it's just a rectangular block. This is in a Rhino environment, design environment, and Rhino design environment typically has these. If you look down at the bottom here, we'll have the XYZ icons. So that is what you can consider a design coordinate system or the world coordinate system. As far as the designer is concerned, that's the world that he's working with. So that's why it's called the world coordinate system. So once that design comes to the manufacturing side of things, the machinists that we are, those of who are machinists here, we'll look at it a little bit differently. We're looking at it from a machine viewpoint. And in most cases, the machine coordinate system, or the way the machine is set up, the X and the Y and the Z axes of the machines, will coincide with the design coordinate system. So here I show you the axes here, the world coordinate axes that our CAM system is displaying. And as you can see, it's parallel to the design system. So everything is fine and good here. In most CAD systems, this is the case. The world coordinate system coincides with the machine coordinate system, and so you don't have to do a lot of mental gymnastics to figure out where you're machining. But there are, in parametric systems like SOLIDWORKS, they have chosen to take the sketch plane, the default sketch plane in SOLIDWORKS is the XZ plane, and so the default coordinate system is not the typical machine coordinate system. So, and also the added complexity in a system like SOLIDWORKS, where you cannot actually transform the geometry once you have designed it. So we'll have to introduce a new transformation between the coordinate system, the design coordinate system, or the world coordinate system and the machine coordinate system. But in this case, in Rhino, everything is fine. So, and then we also have the setup. The setup basically defines additional coordinate systems that allow you to machine parts from different orientations. So the setup one that I have on the left here is basically the same as the coordinate system as the world coordinate system. And then you can, in addition to that, you can have a work zero, which basically moves the coordinate system up to a different point. You're not orienting the coordinate system any differently by using a work zero. All you're doing is transforming it, so it is moving it to a different location. And then you could also define a different setup here, where you can see the Z-axis is actually pointing, or the tool axis is pointing in that direction. What was previously the Y, or the Y axis in the world coordinate system. And then you can also define a work zero in this particular setup. So as you can see, this is my Z axis for this new coordinate system, or the new setup coordinate system. And that's my work zero. That's where I'm going to be touching off the tool when I'm machining from that direction. So that's a quick synopsis of the coordinate systems that we have in CAM. Okay. Let's jump into some of the details of 5-axis machining. The first thing you ought to do when you are looking at the 5-axis machine or machining is define your machine tool. This is the most important thing in 5-axis to get this right. So this is our dialog for defining the machine tool. For those of you who worked with 3-axis, this is very simple. All you do is pick the 3-axis. You're not really concerned about any of the other things. But in the case of 5-axis, you select the 5-axis type of machine, and then you have to define the configuration of the machine. Don talked about the 3 different machine configurations that we support, and those are head, which means the 4th and the 5th axes reside on the head, and then the table head, which means the 4th resides on the table and the 5th on the head, or you can think of it the other way, 4th is on the head and 5th is on the table. And then table, both of the rotary axes are on the tables. So we have different classes of machines. And your machine tool manufacturer and you will let you know which type of machine you have. And it's pretty obvious when you look at the machine. Okay, and then we also have a tool change point that you can define that basically defines where, if you have a tool change and if you want the spindle to retract to that point, you can specify that point here. And then I'll come to this checkbox here, output all coordinates and local coordinate systems in a minute. Then the min-max, you're familiar with that, the translation limits of the machine tool. And then here in the 2 groups here, we have the 4th axis, which defines the primary axis, the 4th axis. And you can specify the rotary center. As you can see, when you select the dark or the thick red arrow defines your rotary axis, and you can select, right now, when you select head, you only have these 2 combinations, either the plus Z or the minus Z. Those are the only 2 things you can select. And then the 5th axis, you can select either the X, positive Y, or negative y, and then obviously since you can't have both of these axes on the same coordinate axis, so this is grayed out. Okay, let's talk about, and then also one important thing that we need to specify is also the axis limit. Some of your machine tools might have some axis limits because of they cannot turn more than 360 degrees, for instance. Some of them who are running on rack and pinion systems could have no limit. But you can define the limits on your machine tool here by specifying this. I'll say 0 to 360 in this particular case. Okay, let's talk about now the output of the coordinate systems, output of the coordinate positions and the angles. So this is something Don alluded to, and I want to delve into it a little bit deeper here. We see three classes of machines out there. Some of the older controllers, which we consider do not have integrated controls, which means they do not understand how all of these 3 or 5 axes interact. So to handle those cases, and especially this applies only for head configurations. If you have either a head or a table head configuration, you will have to define something called the gauge length, which is basically the distance between the pivot point and the tool tip. The reason we need that, I'm going to talk about that a little bit deeper here. Okay, so the gauge length defines that length, and you saw the graphic that Don showed. So let me talk about that here. Let's take a simple case where you have I have a head machine here. I have a display of a head machine. So this is a tool pivot point. This is what Don mentioned in a slide. So we have a 5-axis machine configuration kind of schematically shown here. We have a C-axis. That's basically the C-axis rotates about this. The Z-axis here, the blue line. I'm not sure if you can see it. And then the secondary axis is the B-axis, which rotates about the Y-axis here. And this is where that point is where the tool is actually pivoting about. So as the B-axis rotates, the tool is pivoting about that point. And then this is where you're touching off. This point is where you're touching off. Okay, so if this is your machine configuration, and then you told the machine to move to a certain point. Let's say you told the machine to move to this point. The machine will do it fine, no problem, because it knows its X, Y, Z coordinate system change. So it's just going to take that and do a translation over to here. So you can really think of it, the machine is actually moving this pivot point, and it knows this offset because you've touched it off. You know the tool offset along the Z direction, and so it knows this point, where to move that point. Now in 5-axis mode, it's a little bit more complicated. So let's talk about a 5-axis position. Let's say that's where you have the point that you want to go, but at the same time, you want the rotary axes to be, maybe rotated 90 degrees on the C-axis and then another 90 degrees on the B-axis to get you that configuration so you can attack that other side, come from the other side and machine. So in the case of these old controllers, they are not integrated in the sense that they don't know what the rotary axes and the XYZ motors are doing. They're independent axes. So if you told the machine tool to go to this point, what it's going to do is it's going to do this, because it does not know that the B and the C have rotated. Obviously, you don't want that to happen in 5-axis mode. So our CAM system automatically computes the offsets correctly for you. I don't want to get into the math too much. I don't want to lose you too much, but if you're interested, you can call us and we can give you a position paper on how that's done. So basically, what our CAM system really does is it does a math to backs off by the tool axis vector to that point, and then also uses the tool offset, the Z offset along the Z axis, and this is the point that it actually outputs. So if you look at the G code, you will actually see this point being output rather than this point. But since the rotations are taken place, the machine tool works as you commanded it to work. So this is the one class of machines that we handle. And if your machine is something that uses an older controller that does not do the math in the controls, we do it for you. And the math, the way you define it is by defining the gauge length here. Okay, and the second class of machines, which we see more often, which is kind of like the mid-range set of machines, those actually can handle the kinematic, the math in the controller itself. In those cases, we leave that gauge length to be 0. If you leave it as 0, we know that the machine tool is handling the mathematics behind the rotations. So we will actually output this point to the control rather than this transform point. And then finally, we have these high-end sophisticated machines that actually can do what's known as TCP programming or tool center programming or rotated plane programming. There's different terminology for that. And if you have one of those kinds of machines, you can actually output everything in the rotated coordinate system or the local coordinate system. In this case, we're talking about setup 2. Let's say you rotated your coordinate system to setup 2. Now, all you have to do is you don't even need to output these points in a world coordinate system. You're actually outputting it in this coordinates frame or this coordinate system, if you will. It's a little bit complicated. It'll all be clear when when you do have questions, you can always talk to us about it, and we set it up all in the post processor, so you don't have to worry about it. I just wanted to give you a quick rundown of where things are in terms of the programming part. So it's very important to understand what class of machines that you have, and also set up the output coordinates the way you want it to be. And your controller manufacturer can help you with that when you set up your machine. Okay, I think we spent a lot of time on that. We got about 30 minutes left. Let me cancel this out. Okay, so let's dive into the actual control geometry part of it. So I'm going to load a file here.